all, welcome to the video for Homework 2 Part 2 for CSE373. Hope you guys had a good time with Part 1 of the homework. I do want to point out that this homework actually uses the data structures that you did in Part 1. So when you get your feedback back, make sure that everything's working correctly, because if there's still some lingering bugs in your array dictionary or double linked list, it might end up affecting your results on this part of the homework. So just make sure you're fixing whatever was wrong there. You can get points back for fixing bugs that were in Part 1. If you have an improved score on regrading Part 1 by the time you turn in Part 2, we'll average your old Part 1 grade and your new Part 1 grade, and that will be your final score. If you have any confusion about what a test was testing for so that you can fix it, please come to office hours. The TAs would love to help. Also, I do want to point out once again that this is a part where you should definitely read the entire spec, probably a couple times. There's a ton of implementation details that you don't want to miss. So the project we're going to be doing is a symbolic algebra calculator. The difference between maybe a calculator that you have on your phone and a symbolic algebra calculator is that we have the ability with symbolic algebra to store things as equations and evaluate them later, as we'll see. So a lot of the actual calculator has already been done for you. This is going to feel a little bit weird, especially if you haven't programmed outside of CSE 143 and 142, but it is something that's worth getting used to work in a large code base where you might not understand exactly what's going on in the behind the scenes files. So the only file that you're actually going to be manipulating is called expression manipulators, and you're going to be doing 3 methods there. You're going to be doing a 2-double method, which is you take an AST, an abstract syntax tree representing an equation, and just turn it into the number that it represents. There's also a simplify method, which will take an AST and return not exactly one number, but it will return a simplified abstract syntax tree compared to what was passed in. And you'll also have a plot function, which will take a certain combination of ASTs and plot them on a graph. You're also going to be asked to complete a group write-up with your partner and an individual write-up, which is alone. Your group write-up will be uploaded in your GitLab repo, and the individual will be uploaded to Canvas. So the purpose of the group write-up is to get some practice analyzing your own code. You're going to be running some experiments on your data structures from Part 1, and for the individual write-up, all you have to do is just kind of talk about what you liked about the project, what you think could be changed, and whether you and your partner worked well together. Both of these are graded credit, no credit. They are not meant to be the majority of your time, but you should make sure that you're paying attention to both. So now let's walk through where to find these files. If you go to source, main, Java, calculator, and AST, under all of those you find expression manipulators. Once again, this is the only file that you're actually going to be editing other than your testing files, which are in the same place as normal under test. You have a couple of handling methods and helper methods, and there's a bunch of tips and tricks and implementation details written in the comments here. If you look back on the spec, there's actually a list of files. So expression manipulators is the only one you're going to directly be editing and the only one that you'll be graded on. But there are a lot of other files that might be helpful for reference material as you're trying to understand how these abstract syntax trees are working and what you need to be looking at. If you are looking at a file that's not on the list that we've provided, then that's fine. You should be able to look at all of these, but if you're really trying to understand a file that's not on that list and you've sunk significant amount of time into it, please come talk to a TA. You shouldn't have to look at the back-end code too much. Like we said, a lot of this is learning how to get used to a code base. So once you're done with your code and you want to actually test out the calculator, you can go to main, Java, calculator, and there's a file under there called main under all those packages. So just run it like you would run a test, and it'll pop up with a Java window on your home screen. So once we have it open, we can start trying to plug in some arithmetic. So if we start with 1 plus 2, we'll see that our answer is 3, the simplified version of 1 plus 2. We can also start assigning variables. We can say x, and this colon equals, which is the assignment operator, 5, and it'll return 5, the value of x. We can check that right here. We can also do something like x plus 6 to figure out that x, which is 5 plus 6, is 11. Now, the exciting part about having a symbolic calculator is we can also assign a variable that's an equation, like y is z plus 2. If we set z to 4, then we can test y and see that it's 6. Or if we set z to 8, then we can test y and see that it's 10. We can also try something else. If we do 1 over 2, we'll notice that doesn't simplify, but we can use our 2 double function that you'll write to get a double version of that expression, which is going to end up being 0.5. And the last kind of trick that we can do is the plot function. So if we plot the equation a times a squared, where our variable is a, and we plot a going from -10 to +10 in 0.1 step increments, we can see that we come up with this cool little quadratic chart. Hopefully this has answered your questions. If you have any lingering questions, please go to office hours. We love to help. See you soon.